Okay, so this is the continuation of projectile motion. This is lesson 3. So do well to check my YouTube channel for lesson 2 and lesson 1 so that it will be more clear, or it will be clearer to you if you watch this lesson 3. So now we still have a diagram here, and of course we have an object that is being projected at an angle with a particular velocity, at an angle with the horizontal with a particular velocity. And the question here is, when the object gets to the maximum height, what will be the acceleration? Or can we say that the object is accelerating or experiencing the force of gravity when it gets here? And of course, we know that the acceleration is acting in the vertical direction. And of course, the object at every point on this curve will experience a force of gravity. So it means that no matter what, even if the object gets to this maximum height, it will still experience the force of gravity. So it means there will be a value for the acceleration, and it will still be 9.8 meters per second square. So, but there is no horizontal version of gravity. Gravity does not act in the horizontal direction, only in the vertical direction. So there will be no acceleration in the horizontal direction. It means the horizontal component of the speed of the velocity will remain the same at every point on the curve. It will not increase. It shows that it's not accelerating, and it will not reduce. No retardation also. So, but what will happen since we now know that there is actually a value for the acceleration at this point in time, there's a force of gravity. The force of gravity is still acting on the object at this point, at the maximum height. What will now be the value of the horizontal component of the velocity at this point in time? Of course, we know that this is a shortcut for getting the horizontal component of the velocity, v cos theta. And of course, the velocity vector is making an angle of 0 degree with the horizontal. So I'm going to fix 0 here. It now becomes v cos 0. And cos 0 is 1. That will be 1 times the v gives you v. So that means that the horizontal component of the velocity will have a value. It's not going to be 0. It's now going to be equal to the v cos theta, which is for the horizontal component, will now be equal to the v. That's the resultant velocity at this point in time. To now be equal to each other. But what about the vertical component of the velocity here, of this velocity of this object here? We know vertical component is what? V sine theta. So if we're now fixing the value of the theta, I know theta is still 0 degrees. The velocity vector is making an angle of 0 degrees with the horizontal. So it will now be sine 0, and sine 0 is 0, then 0 times v is 0. So that means the vertical component will be 0 at the maximum height, following v sine theta. Of course, v sine 0 degrees, which will give you 0 times the v. So the vertical component will have no value. It will be 0 at the maximum height. So that's that for this one. Then we have another illustration here. We have a diagram here, and in this diagram we have an object A and object B. Object A is left to fall from a particular height, and object B is also left to project this way with a particular, or is projected this in the horizontal with a particular velocity from the same height, and it forms a trajectory, forms a curve, and it falls down following or creating a curve. And to your surprise, you'll be shocked that if the object A falls from this height and gets to the ground in 4 seconds, object B will also fall from this height, creating that curve in 4 seconds too. And why is it that way? It is because the object B, while falling and creating this trajectory, at every point on this curve it is creating, it has a vertical and a horizontal component, and the vertical and horizontal component do not depend on each other. They are independent of themselves. So we can just assume to just focus on the vertical component and see. And if you check, the vertical component at every point here is the same as the one here. So the vertical component here and here are the same. The vertical component here and here are the same. And the vertical component here are the same. So definitely they will fall at the same time. So that means if they give you a question like this, so this diagram looks exactly like this. So this is the height, and of course this is the velocity, the horizontal component of the velocity. And don't forget that the horizontal component remains the same at every point on the curve. remains the same. The horizontal component remains the same at every point on the curve. Only the vertical component increases as it's falling down. Why is it increasing as it's falling down? Because the force of gravity is acting on the object. It is accelerating while it is falling down. And of course, acceleration doesn't act in the horizontal direction, it acts in the vertical direction. So don't forget that parcel A and parcel B, no matter how long the curve is, they will get to the ground at the same time. So here to the same thing. Imagine the object is here and it falls this way, or it is being projected this way and it falls down this way. If it falls from here to here in 5 seconds, it also falls from here to here in 5 seconds also. Very interesting thing about projectiles. So we're going to go further in lesson 4, so stay tuned and don't forget to subscribe to my YouTube channel. Stay blessed.